Good morning, Year 6. I have to start off with a little apology because I realised I made a mistake on my video yesterday where the date changed on one slide but then I didn't change it on the other. It still said the 2nd of June and most of you probably didn't even notice, and now here I am pointing it out. But, well, it's done now. So, moving on to today's lesson. Today is the 4th of June 2020. And I think it's really important I try and keep you up to date with the dates, because I know probably those of you at home probably forget what day of the week it is and what date it is. So it's the 4th of June 2020. Make sure you're writing the date in Roman numerals as well and writing our learning intention, which is to find possible combinations of two variables. Is now shown on the screen, so make sure you've got those written down correctly. Paper, 5-minute timer, and your thinking hats on. Let me know when you've got all of that. Check. Just 12 questions. Pink being the easiest and green being the most difficult. See how much of it you can complete within 5 minutes. And if you manage to complete it in less than 5 minutes, see if you can beat your time each day. Fantastic, and we'll go through the answers. So, 48 plus 824 is 872. So the easiest way to do that is to do 824 add 40, which is 864, and then add on the 8, and you get 872. 3/10 minus 1/10 equals 2/10, and if you simplify 2/10, you get 1/5. 2 times 75 equals 150. 5 times 4 times 10. 5 times 4 is 20, and 20 times 10 is 200. We know when it's all the same operation, we just work from left to right. Whereas when there are different operations, we need to follow the laws of the order of operations. Okay, but otherwise, if it's the same operation, just work from left to right. 3,050,020. Now that's a large number, so I hope you read it correctly. And the missing number there was 50,000. The 50,000 was missing. So the key there is to read it correctly. As long as you've read the number correctly, you'll be able to write down the missing number easily. 270 divided by 3. Well, let's ignore the 0 for now. 27 divided by 3 is 9. So 270 divided by 3 is 90. Always look for a pattern in numbers. Always, always, always. Because the pattern will always be there. And once you identify the pattern, it helps make it very easy to find the answers. 6 squared plus 10. So 6 squared just means 6 times 6. And then we add 10. So we know that according to the order of operations, we must do the indices before addition. So 6 squared, 6 times 6 is 36, add 10, 46. Something minus 10 equals 298. So that's quite similar to what we've been doing as part of our algebra unit. So it could easily be x minus 10 equals 298, and you have to work out the value of x. So in this case, we do the inverse, 298, we add 10 instead of minusing 10, and we get 308. So that's our answer. 5,400 divided by 9, ignore the zeros, and let's just do 54 divided by 9. What is that? That's right, it's 6. And then we remember to put our zeros back on. There were 2 zeros, so we put 2 zeros back on, and we get 600. 0.1 divided by 100. Well, we know if we're dividing, our number's going to get smaller. We've already got a teeny tiny piece, less than a whole, and now we're going to split it into 100 smaller pieces. So we know our number is going to get smaller, which means we're moving further into decimals, we're moving further to the right. So you'll see in the number 100 there are 2 zeros, so we need to move our number 2 spaces to the right. Okay, just like the 2 zeros in 100. So once we've done that, we end up with the number 0.009. Now for the next one, 75% of 2,000. What's 75% of 100? That's right, it's 75. So if you know that, what's 75% of 1,000? That's right, it's 750. But what is 75% of 2,000? Well, if 75% of 1,000 is 750, 2,000 is just double 1,000. So we do the same with the 75%. We double that too. What's double 750? Well, let's look over at the pink side. Third question down. 2 times 75 is 150. So 2 times 750 is 1,500. And last but not least, 5/7 plus 3/21. Now we need to see if we can find a common denominator here. And we know that if we divide, if for us to get the 3/21 down to 7ths, we'd have to divide by 3. And we can divide both of those numbers, have factors of 3, so that works. 3 divided by 3 is 1, 21 divided by 3 is 7. So now we have 1/7. 5/7 plus 1/7 equals 6/7. Well done if you managed to get those. Some key vocabulary which you'll need to know in this lesson. The first one is integer. An integer is a whole number. Substitution means to replace a number with a letter. And methods that we're going to be discussing in our lesson today are trial and error, which is when you just try any combination and see whether it works, or working systematically. So people either choose one or the other. Okay? Working systematically means to work through in order following a system. Okay? Rather than just saying, yeah, I'll just try that combination. We say, actually, I need to try that one, then I'm going to match it up with this one and this one and this one, and then I'll move on to the next one. So it's following through a system. And hopefully today, we're going to be more working systematically as opposed to just using trial and error. Trial and error is great and it is really useful, but when we're asked to find all the possible solutions or all the possible answers, it's best to work systematically. Good idea to just write down those words as well to make sure that you have the definition in your books. So going back to what we said about working systematically, here is a perfect example. I'd like you to list all the 2-digit numbers that can be made using these digit cards. Think about what strategies you can use to help you. How can you work systematically to make sure you found all of the 2-digit numbers? Not that you just plucked 1 and 2 and 3 and 4 out of the air, but that you've actually made sure you have exhausted all the possible answers. I want you to pause the video here and have a think about the way that you can work systematically to find all the possible 2-digit numbers that can be made. And here are the answers. So you could have, first of all, started off by looking at the number 1 and saying, okay, if I was to just put 1 in the tens, what numbers could I match it up with? So 1 in the tens could give me 1 and 5, 15, 1 and 3, 13, 1 and 2, 12, 1 and 6, 16. So that's all the ones in the tens. It's been exhausted. Then you could have said to yourself, well, what if I put all the ones in the ones column in our place value? And then you would have said, okay, 51, 31, 21, 61. So working systematically is saying, okay, now I've done every possible number that they can be with a 1. Now I'll move on to the 5s or the 3s or the 2s and the 6 and working through each of them to make sure that you have got all of your answers written down. If you just sat and plucked them out of thin air, then it's likely that you probably missed quite a few. So if you did manage to get all 20 of them, then well done you, because that means that you probably did work systematically. And that's going to help you in our lesson today. Thinking about what we said, here are some flowers and some vases. Now, this young lady says, I choose 2 flowers to put in each vase. List all the possible combinations. Can I still use multiplication to help me find all the combinations? So think about how you would work systematically to make sure that you have put 2 flowers in each vase and thinking about all the different combinations. So yes, you might put flower A and B in the pink one, but then you might also put flower A and B in the blue and flower A and B in the green. And then you'll do the same with another two. So think about all the possible combinations. Pause the video here and write those down. Through the answers. We can't use multiplication to find the number of possible combinations here. We have to make sure we're using our systematic way of listing the combinations. We know that there are 4 different flowers and I choose 2 different ones each time. So this gives me 6 different combinations. Well done if you managed to get the 6 different combinations. However, with those 6 different combinations, we know that there are 6 different combinations and 3 different vases. So we know that with those combinations, if we were to put them in each of the different vases, then that gives us, those combinations could then be multiplied by 3, meaning that there are 18 possible combinations in total. You might want to pause the video here and just look at how we managed to get 18, just checking that they're all different. Every vase should be different, whether it's a different vase or a different plants in different flowers in the vase. Well done if you managed to get those. Bunting to decorate my room. I have a mix of purple and green flags on my bunting. Purple flags have 4 stars on. Green flags have 5 stars on. In total, there are 100 gold stars. List all the combinations of green and purple flags that could be on my bunting. So pause the video here and have a go and see if you can list all the different combinations. If you're finding it tricky, here is some extra help. One purple flag has 4 stars on it. If I subtract this from 100, the total number of stars, this means that there would have to be 96 stars on green flags. So we know there's 100 in total. So if we take away the 4 on the purple stars, then we've got 96 left. But we know that that can't be right because on the green flags, they each have 5 stars on. And 96 is not a multiple of 5. So there can't be just one purple flag. That is not a possible combination. Can you predict the next number of purple flags that will fit the equation? Do you think that we could have 2 purple flags? Is that possible? 2 purple flags would mean that we have 8 stars, and that would mean that we have 92 stars left. Is it possible that we can have 92 stars left from the green flags, which only have 5 stars each? It can't be because 92 is not a multiple of 5. So, if you have a look at the table shown so far, you can see that if we have 5 purple flags, we couldn't have 3, we couldn't have 4, we'd have to have at least 5 purple flags, which means that then we'd have 16 green flags. 16 times 5 is 80, and 5 times 4 is 20, which equals 100. Whatever combination we do, we must always make sure that we have 100 stars in total. We could also do the same with 10. We could have 10 purple flags and 12 green flags. And you'll see how that works on the screen in brackets. We could do the same with 15 purple flags and 8 green flags. 20 purple flags and 4 green flags. 25 purple flags and 0 green flags. So, can you explain on your papers any patterns you can see in the combinations? And how you can use this to know you found all possible combinations? Excellent. So your explanation should look like this. As the number of purple flags increases by 5, the number of green flags decreases by 4. So, now we've looked at all of those Bunting questions, some of which might have made sense and some of it might have not. So, I think it would be a good idea now to have a go at making your own bunting. I want you to get some coloured paper or card, or just paper if you haven't got any of that, and create 2 different colours of bunting flags. Choose a shape and then decide how many of that shape you will have on each colour of flag. So you might have 2 triangles on a red flag and 3 triangles on a green flag, for example. And then I'd like you to investigate the possible combinations of your 2 flags to make different totals of shapes. Okay, so you might want to set yourself a target and say, oh, I'm going to have 20 of those shapes in total, or I might have 50 of those shapes in total. Okay, so try it with different targets and see how you can, the different combinations that you can make, just as we did on just as we looked at on the last example shown. Next, so you'll see that this morning you were sent some work. So you've got 3 different challenge levels, which you'll recognise from our books at school, our target maths books. I'd like you to choose the challenge level with which you feel most comfortable. There are examples at the top of the page, and choose A, B or C. So choose your level of difficulty and complete the task. As an extension, for those of you that want to push yourself, I've also sent you some additional work this morning, which is more problem solving, which I'd like you to have a go at as well. Email us your work at yr6@grange.harrow.sch.uk. Have a great day, Year 6. Bye.